Now we are starting 3.5.4 Silicons. The chemistry of silicon is in many respects very much like chemistry of carbon. Just as carbon forms the compounds carbon dioxide, carbon tetrachloride and methane, similarly silicon forms silicon dioxide, silicon tetrachloride and silane. The silicon atom holds four methyl groups SiCH34 just as the carbon atom CCH34. If a compound of silicon containing chlorine atoms and methyl groups Si2, SiCl2, CH32 is allowed to react with water, hydrogen chloride comes out and the silicon atoms join together through oxygen atoms. As you can see in the structure. By this reaction we can make symmetrically synthetically the silicon-oxygen chains found in mineral silicates, which we have been just discussing. A difference is that here we have minus CH3 groups instead of oxygen atoms joined to silicon as side chains. Such a compound is called silicon. This particular one is a methyl silicon. Other alkyl groups may also be substituted for the methyl groups, another and the molecular chain can be made of various lengths. Properties and uses of silicons. Some of the methyl silicons are oily liquids and they become more viscous as the chain length increases. They are used as lubricants, either incorporated in greases or as oils in bearings, gears, etc. They are also used in hydraulic brakes and other hydraulic systems. The outstanding physical attribute of silicon oil is its very small change in viscosity with change in temperature compared with the behavior of other oils of similar viscosity. If the temperature is dropped from 100 degrees Celsius to 0 degrees Celsius, the viscosity of petroleum oil may increase about 100 folds, whereas that of silicon oil will increase less than 4 folds. In the presence of air or oxygen at temperature as high as 300 degrees Celsius, silicon oils remain free from acid formation. Oxidation and similar phenomena which frequently limit the usefulness of petroleum products and other synthetic organic liquids. Methyl silicons of high molecular mass resemble rubber and are used in making rubber-like tubing and sheets. Silicon molecules can be made in such a way that bridges or cross-linkages bind one long molecule to another at several points along the chain. These compounds have resinous properties and are extensively used in electrical insulation. Another interesting and important application of silicons is their use in treatment of various surfaces to make them water repellent. A silicon film covers the surface and repels water like a grease film. Much of the leak of electricity through the moisture film on ceramic electrical insulators can be prevented by a silicon film. Cloth, plastics, asbestos, glass, leather, and paper, even filter paper and blotting paper become strongly water repellent when covered with a silicone film.